You know, okay. Here we go. Okay. All right. So again, this is here. So this is what happens. So we just saw what happens if you change the mean and standard deviation. That's actually on the, what do you call it, the next slide. Let me just make this bigger. There we go. See? So this is what, for instance, this is what happens if the mean is 5 and the standard deviation is 2. You could actually obtain the graph from the Desmos thing we just had. You know, you can see here, hopefully you can imagine, here, maybe this will help. Bear with me. I'm going to try and draw this line. It might be semi-vertical, but hopefully you can imagine drawing a vertical line about through the mean, which is 5 in this case. It might be hard to, it might be a little hard to see, but the graph is symmetric about it. You know, if you imagine taking the graph and folding it like a piece of paper, or folding the Cartesian plane about that vertical line through the mean, both halves of the graph would line up. That's what we mean. And the standard deviations too. Okay. So we did some drawings already, so I'm not going to draw it again. But this is basically what we noticed, that the smaller the standard deviation is, the narrower the graph will look. And the peak will be higher up. You know, the peak, again, the graph looks something like this. The peak is going to go up if the standard deviation gets smaller. I mean, basically because what's going to happen is the data is going to be centered more around the mean. You know, there's more data around the mean, so the frequency goes up. Whereas if it's larger, the standard deviation, okay, if it's larger, then what happens is the data is more spread out, so the graph's going to look flatter. Okay, and you can see the peak is where the mean is, right? Going back to this graph, for instance, the peak here is where the mean is. Let me see if I can get here. Over here also, the peak is where the mean is. So by shifting the mean, you're shifting the graph horizontally. Okay. Are there any questions about this? Okay, that's just some characteristics about the graph. Now, here are some other results. The book actually calls this the empirical rule. Okay, I'll show you a picture from the textbook as well. Most of the data, well, I shouldn't say, well, I guess I could say that, about 68% of all data values, right? Remember, the curve lets us approximate not only the values of the distribution, okay, the values of the variable that is, but also the frequency. Well, about 68% of the data values are within one standard deviation of the mean. Okay? About 95% are within 2 standard deviations, and 99.7% are within 3 standard deviations. I mean, we did already say that most of the data is within 3 standard deviations. That's what this is saying here. We did say it already. Let me show you the text. Let me show you the textbook picture. Keep the ink. Yeah. All right. Let me show you that as well. Okay. I had to stop sharing it. I know it's annoying, but what are you gonna do? This should be it here. Oh wait, let me actually go here. There it is. Okay, can everyone? Okay. So hopefully you can see this. Let me zoom it in a bit. You know, it's a PDF. It's the textbook. It's chapter 12. File claims. Yeah. But here's what they mean by the empirical rule. You can see that here, the area under the graph, most of the data here, as you can see, is within 1 standard deviation of the mean to the right and left. 68% of it, okay? I'm not going to mess with that. 68% of it, actually. Let me see something, actually. Let's see if I can get that here. On. All right, here we go. This is better. Okay. hopefully you can see that though, okay? And 95%, most of the data is within there, okay? And 99.7% within 3 standard deviations. I mean, we did say this already, that the further from the mean you go, the more rare, that is, the smaller the frequency of the data values. Okay? And they're just saying most of it's within 1 standard deviation. Most of it is within 3 standard deviations. So, and again, this is in the textbook, so just letting you know, no surprises there. All right. So this is what they call the empirical rule. All right. Are there any questions about this? Okay. All right, let me get back to the notes. Stop sharing this thing. Okay. Good, there it goes. Okay. So we have this. So here's an example actually dealing with this. We can actually use, if we know that a variable, whatever it is, in this case test scores, are normally distributed, if we know the mean and the standard deviation, we can actually determine where most of the data is going to be. So for instance here, I'm telling you that for a test where the score is at a 15, it turns out that the scores are normally distributed with a mean of 8, standard deviations 2. You know, somehow we know that already, okay? So what the empirical rule is telling us is this. If you did the mean plus 1 standard deviation, so 8 plus 2, which is 10, okay? And 8 minus 2, 1 times 2, that's equal to 6, right? Most of the test scores are going to be between 6 and 10. So in other words, most students, their score is between 6 and 10. I mean, some I'm sure got a perfect score, but it's not that rare. But excuse me, it doesn't happen that often. That's 68% of the students, that is, about. That's a better way of saying it. Okay, let me fix what I just said. About 68% of the students who took the exam, their score was between 6 and 10. Okay? Of roughly 68%, okay? Now here we have 2 standard deviations in each direction, okay? So here we have 8 plus 2 times 2, right? The standard deviation is 2, the mean is 8, so we have 12. Here we have 8 minus 2 times 2, which is 4. Yeah. So about 95% of the test scores are between 4 and 12. And then finally, this is 3 standard deviations, greater and less than, okay? So almost all test scores, about 99.7%, are between 2 and 12. 2 and 12. And here's actually a graph showing that. I think this graph I actually drew using that Desmos thing we just saw. Okay, so this is what we get from the empirical rule. This is, you know, what I just said. Okay, and again, this distribution pops up a lot. Normal distribution. I want to say it pops up the most. I could be wrong about that, but I know it does pop up a lot. Okay, many different places. Okay, that's why so many people are interested in this and so many people like to work with us. Okay, here's actually another example. Let's suppose we have a normal distribution, okay, with a mean of 34. And let's say the standard deviation was only a half. So we can use the empirical rule, right? We have here 68% of the data is within 1 standard deviation, meaning 34 minus a half is 33.5. 34 plus a half is 34.5. 68% of the data values are in here. So whatever, variable has this distribution or is approximately distributed this way with a normal distribution with this mean and this standard deviation, this is what we get. Okay. 95% is within 2, as you can see here. So here's where you subtract 2 standard deviations. So 2 times a half and 2 plus a half. Excuse me, 34 minus 2 times a half, that's 33. 34 plus 2 times a half is 35, okay? Then you have 99.7%, which is this, as you can see. So most of the data is here, okay? Now this one I was gonna have everyone try right now, okay? Good. So let's do this. So let me see how much time we got. We're so on time. Let's just do this one together, okay? We have like 7 minutes left. I just feel better if we did this together, okay? All right, let's do that. So let me get the